बिस्मिल्लाहिर्रहमानिर्रहीम। अल्लाहुम्मा सल्लि अला सय्यिदिना व मौलाना मुहम्मदिन व अला आलि सय्यिदिना व मौलाना मुहम्मदिन व बारिक वसल्लिम। रब्बि इश्रह ली सदरी व यस्सिर ली अमरी वहलुल उक़्दतम मिन लिसानी यफ़क़हू क़ौली। Assalamu alaikum. I am Dr. Umar Farooq. Dear students, this is our last lecture of chapter 1, in which I'll talk about those topics which are yet to be discussed. And these are physical and chemical properties, classification and occurrence of elements, and calculation of mass ratio in a compound. Actually, these topics were irrelevant with the story that I told you from lecture 1 to 7. Watch the intro of my lecture number 7 from 0.28 to 1.57 minute. You will find the answer why I didn't follow the sequence of your book. So here's the intro of lecture number 7. So students, this is the flow chart which we constructed in 6 lectures. Firstly, we studied about various types of matter. Then I talked about particles on which matter consists of. After that, representation of these particles was studied. In the next lecture, I discussed about masses of these particles in AMU unit. And in the last lecture, we studied about masses of these particles in gram units, which is called a mole and contains exactly Avogadro's number of particles. So my first target was to develop this flowchart. इसीलिए मैंने अपने लेक्चर्स में सिर्फ उन चीज़ों का जिक्र किया जो इस फ्लोचार्ट से मुताल्लिक थीं। बाकी जो टॉपिक्स रह गए हैं वो अगले 2 से 3 लेक्चर्स में मुकम्मल हो जाएंगे इंशाल्लाह। अब सवाल ये पैदा होता है कि इस फ्लो चार्ट पर मैं इतना फोकस क्यों कर रहा हूं और आखिर इसकी अहमियत क्या है। तो जवाब के लिए पेश है आज का लेक्चर which deals with the mass, mole and particle calculations, यानी numerical problems. So students, listen to my words again and try to understand the sequence of my teaching. I hope you will understand this. Let's start today's lecture now. Students, if you recall the first lecture of mine, I defined chemistry as the branch of science which deals with the study of composition of matter, structure of matter, properties of matter which are of two types, that is physical properties and chemical properties, and changes in matter which are also of two types, that is physical changes and chemical changes. At that time I didn't discuss these terms and left for this last lecture. One more thing, physical and chemical changes are not included in your syllabus. But you cannot grab the concept of physical and chemical properties without understanding these terms, that is physical and chemical changes. So it's my duty to explain the physical and chemical changes first. Consider the following processes. Watch this video. Put some yellow powdered sulfur and black powdered iron in a watch glass and mix them thoroughly at room temperature. What happens? We get a mixture of iron and sulfur in which both iron and sulfur retain their properties. यानी iron iron ही रहता है और sulfur sulfur ही है. So iron can be separated with the help of a magnet. Iron is attracted with the magnet while sulfur remains in the dish. So this simple mixing is called physical combination or a physical change. Such a change is a temporary change and can be reversed easily. Now, if the same mixture is heated in a test tube Then a grayish black solid mass is formed, which is a compound named iron sulfide, and its chemical formula is FeS. This time, iron and sulfur have chemically combined with each other. That is, iron and sulfur atoms have joined by chemical bonds. And therefore, we cannot separate iron and sulfur with the help of a magnet. So this combination is called a chemical combination, and this change is known as a chemical change, which is a permanent change, of course, and cannot be reversed easily. So, a mixture is formed as a result of physical combination, while a compound by a chemical combination or a chemical reaction. A chemical combination or a chemical change occurs when atoms join together through chemical bonds, and as a result, new substances are formed. Whereas physical combination or physical change occurs without any bond breaking or bond formation, and no new substance is formed. I hope you understand. Let us now differentiate physical and chemical changes. During a physical change, the chemical identity or chemical composition of a substance remains unchanged, while chemical change is that change during which chemical identity or chemical composition of a substance changes. No new substances are formed during a physical change. Since the identity of a substance changes during a chemical change, so it is converted to a new substance. Physical change is a temporary change and therefore can be reversed easily. On the other hand, a chemical change is a permanent change and hence cannot be reversed by simple physical methods. Individual properties are retained during a physical change, whereas in a chemical change, individual properties are lost. Here are a few examples of physical and chemical change. Melting of ice is a physical change because the only thing changing is its physical state. Its chemical identity, that is H2O, does not change, whether it is ice or liquid water. Similarly, boiling of water is also a physical change because when water boils, it is still water. And the formula of steam is also H2O. When ice cream melts, only the physical appearance of the ice cream change. Its chemical composition remains the same, and the ice cream can be frozen back to become the same ice cream. Dissolving sodium chloride, that is table salt, in water, the water and sodium chloride retain their chemical identities and can be separated by physical methods. So, dissolving is also a physical change. Now, chemical changes. Burning of candle or anything is a chemical change because the candle does not remain the same candle anymore. And once it is burnt, there is no way we can get it back. Boiling of egg is a chemical change because once the egg is boiled, you cannot bring it back. Rusting of iron is a chemical change because during rusting, iron combines chemically with atmospheric oxygen to form a compound iron oxide, which has totally different properties from iron or oxygen. Digestion of food is also a chemical change because once the food is digested, there is no way it can be reversed. Now, come to the actual topic, properties of a substance. As you know that properties are just characteristics of a substance and they are of two types, physical and chemical properties. A physical property describes an observable change in the characteristics of a substance but does not affect the chemical makeup of that substance. That is, its identity remains the same. It is observable when substances do not undergo chemical reactions. On the other hand, a chemical property describes the characteristics of a substance that will change the chemical identity or chemical makeup of that substance. And as a result, new substances are formed. It is observable only when substances undergo chemical reactions. Let me first elaborate physical properties. Physical properties of a substance are observed without any change in its chemical composition or chemical identity. यानी किसी सब्सटेंस की फिजिकल प्रॉपर्टीज़ का मुशाहिदा करने के दौरान उसकी केमिकल कॉम्पोजिशन में हरगिज़ कोई तब्दीली वाक़ई नहीं होती, सिर्फ ज़ाहिरी शक्ल सूरत या फिज़िकल स्टेट में तब्दीली वाक़ई होगी. So, these properties are associated with the physical state of a substance like color, hardness, shape or structure of crystal, solubility, viscosity, melting or boiling points, etc. Now note this. Boiling is a physical change, but boiling point is a physical property of a substance. Similarly, melting is also a physical change, but melting point is a physical property. Dissolving is a physical change, but solubility is a physical property. And what is solubility? Solubility is the ability of a substance to be dissolved. यानी किसी सब्सटेंस के डिज़ोल्व होने की सलाहियत कि वो कितनी मिकदार में डिज़ोल्व होगा या हल होगा. Rolling a metal into sheets is a physical change, but malleability is a physical property of a metal. And malleability is the ability of a metal to be rolled into sheets, यानी किसी मेटल की शीट्स बनाने की या शीट्स में कन्वर्ट होने की सलाहियत को उसकी malleability कहा जाता है. Drawing a metal into wires is a physical change, but ductility is a physical property. And ductility is the ability of a metal to be drawn into wires, यानी किसी मेटल की तारें बनाने की जो सलाहियत है उसको उस मेटल की डक्टिलिटी कहा जाता है. Hope you understand. Let me further elaborate physical properties. Boiling of water is a physical change, but boiling point of water, which is 100 degrees Celsius, is its physical property, as it does not tell us how that water is going to react with other substances. It just tells us that at 100 degrees Celsius, this liquid substance is going to turn into vapors, which is a physical change. यानी 100 डिग्री सेल्सियस जो कि पानी का बॉइलिंग पॉइंट है हमें सिर्फ ये इन्फॉर्मेशन देता है कि इस टेम्परेचर पर पानी से भाप बनेगी और पानी किस तरह से रिएक्ट करेगा दूसरे सब्सटेंसेस के साथ, इस बारे में कोई इन्फॉर्मेशन प्रोवाइड नहीं करता उसका बॉइलिंग पॉइंट जो कि उसकी फिजिकल प्रॉपर्टी है. नेक्स्ट वी हैव dissolution or dissolving process. Dissolution of sodium chloride in water is a physical change. अब ये क्यों है physical change? Because both water and sodium chloride retain their chemical identities and can be separated by some physical method. But solubility of sodium chloride is a physical property, which means the amount of sodium chloride dissolved in water. Here are some physical properties of iron: magnetic property, thermal and electrical conductivities, hardness, melting point, malleability, ductility, etc. ये physical properties हैं iron की. But its ability to rust, जंग लगने की जो सलाहियत है लोहे की, this is its chemical property. Its reaction with sulfur to form iron sulfide is its chemical property. और अब हमारा अगला टॉपिक भी यही है, chemical property. Let us first define chemical properties. Chemical properties of a substance are observed when the substance undergoes a change in its chemical composition or chemical identity. यानी किसी substance की chemical properties उस वक्त observe होती हैं जब उसकी chemical composition तब्दील हो. Now note these words carefully. Being oxidizing is a chemical property of a substance, but the process of oxidation is a chemical change. Being reducing is a chemical property of a substance, but the process of reduction is a chemical change. Similarly, being corrosive is a chemical property of a substance, but the process of corrosion is a chemical change. इसी तरह, combustibility is a chemical property of a substance, but the process of combustion is a chemical change. यानी कोई सब्सटेंस अगर ऑक्सीडाइजिंग है या रिड्यूसिंग या करोसिव या कंबस्टिबल है तो ये उसकी केमिकल प्रॉपर्टीज़ हैं, लेकिन ऑक्सीडेशन, रिडक्शन, कोरोजन और कंबस्शन उसमें होने वाले केमिकल चेंजेस के नाम हैं. कंसिडर अनदर एग्जाम्पल. There is a property of iron to rust, during which iron combines chemically with atmospheric oxygen to form a compound iron oxide, and therefore it is the chemical property of iron, because iron loses its identity and is converted into a new substance. So, to rust is a chemical property of iron, but the process of rusting is a chemical change in iron, because iron and rust both have different compositions and properties. Hope you understand. Next we have classification and occurrence of elements. In the early ages, only 9 elements were known to man, and those were carbon, gold, silver, tin, mercury, lead, copper, iron, and sulfur. Out of these, carbon and sulfur are non-metals and rest are metals. 19th सेंचुरी के एंड तक 63 एलिमेंट्स डिस्कवर हो चुके थे और अब आज तक 118 एलिमेंट्स डिस्कवर हो चुके हैं, जिनमें 92 नेचुरली अकरिंग एलिमेंट्स हैं और बाकी मैन मेड या सिंथेटिक यानी मसनूई. And all of these elements are compiled in the form of a table called periodic table of elements, which is given at page number 48 of your textbook. Let's talk about natural occurrence or natural abundance of elements. Elements occur in nature in free or combined form. All the naturally occurring elements found on Earth have different percentages in the Earth's crust, oceans, and atmosphere. Following table shows natural occurrence in percentage by weight of some major elements around us. In Earth's crust, oxygen is 47%, silicon 28%, and aluminium 7.8%. So, 82.5% of the Earth's crust is made up of 3 elements: oxygen, silicon, and aluminium. In oceans, we have 86% oxygen, 11% hydrogen, and 1.8% chlorine. So the 98.8% of the oceans consists of just 3 elements: oxygen, hydrogen, and chlorine. And 99.9% of the Earth's atmosphere consists of 3 gases: nitrogen, oxygen, and argon. Let's have a look at the distribution of elements in the periodic table. Look at this periodic table. On the basis of their properties, elements are divided into metals, nonmetals, and metalloids. According to the key, the elements written in blue boxes are all metals. About 80% of the elements are metals. The elements in green boxes are metalloids, which show the properties of both metals and nonmetals. And the elements in yellow boxes are nonmetals. Elements may be solids, liquids, or gases. Majority of the elements exist as solids. For example, sodium, copper, zinc, gold, etc. There are few elements which occur in liquid state. For example, mercury and bromine. A few elements exist as gases. For example, nitrogen, oxygen, chlorine, and hydrogen. Now look at this periodic table. And according to the key, the elements in green boxes are all solid at room temperature. And you can see that majority of the elements exist in solid state. The elements in blue boxes are liquids. For example, bromine and mercury. The elements in yellow boxes are all gases. Hope you understand. So we have come to the end of today's lecture, and at the end I want to tell you how to calculate the mass ratio in a compound. But first let me define what is a compound. As you know, students, that a compound is a substance made up of two or more elements chemically combined together in a fixed ratio by mass. And how do we calculate that fixed ratio? For this purpose, consider this example. Carbon dioxide. The formula CO2 shows that one atom of carbon is combined with two atoms of oxygen. Since atomic mass of carbon is 12 and that of oxygen is 16, so we have 1 times 12 ratio 2 times 16. Simplifying, we get 3 ratio 8. So in carbon dioxide, carbon and oxygen are in a fixed ratio of 3 to 8 by mass. Consider another example. In water, hydrogen and oxygen are combined in 2 to 1 ratio. That is, 2 atoms of hydrogen are combined with 1 atom of oxygen. Since the atomic mass of hydrogen is 1 and that of oxygen is 16, so we have 2 ratio 16. Simplifying, we get 1 ratio 8. So it is concluded that in water, hydrogen and oxygen are in a fixed ratio of 1 to 8 by mass. Hope you understand. If you have any questions, please don't hesitate to ask. Thank you.